your paper, you're going to do a rotation first, and we're going to do this rotation with this quadrilateral that's A, B, C, D, and you should have already located your coordinate points or your vertices, where A would be 2, 4, so that would be 2, 4 right here, and B would be 4, 3, so 4, 3 right here, and then you have C, which is 2, 1, and D here, which is 1, 2. So those should be the 4 coordinates that you have already located and put on your paper. So we're going to do a rotation, and we're talking about rotating this thing around the origin. The origin is right here, and so what we do is we're gonna rotate this 90 degrees. 90 degrees is when you just flip it one full turn to the right or to the left. I'm gonna do clockwise. We say it's 90 degrees. Clockwise, counterclockwise would be this way. So I'm gonna actually rotate this thing, pick it up, and rotate it so that it ends up here. We need another little piece of tape to kind of put that here. So now what happened was, remember this was Y and this is my X, was my X, and so when I rotate it, just think of this as being my X axis right here, so this would be my Y. Also notice that these are positive and these are negatives, and these would be positives and these would be negatives, but when I rotate it, the negative signs and positive signs, so just kind of ignore those right now and see where this point is now. So this new point A is going to be at 4, -2. So you want to write down the 4, -2. The B would be at 3, -4. The C would be at 1, -2. And your D would be at 2, -1. So that's the next thing that you want to record. So when I did a 90-degree rotation, turn it this way, remember it was like that, and then we just rotated it this way. All right, so now the next one we're going to do is what's called a reflection. And think about this for a minute. If you look at yourself in the mirror, you see a reflection of yourself. And if you were to ever, things are kind of backwards when you look in the mirror. So what we're going to do on this one is what I want you to do is to we're going to reflect this across the x-axis first. And then we'll see what happens when we reflect it across the y-axis. So when I reflect it, it's going to be a mirror image down here. And the way we want to do that is I'm going to fold this piece of paper right across my x-axis. I'm going to take this down here for a minute so we'll see what that looks like. Do the best job as you can. You should be doing this right now. And you should be folding it in two like that. And if I look over here on the other side, you can kind of see through it, not really. But what I'm going to do is I'm going to take my pen and I'm going to put another dot right here, a dot right here. I didn't fold it exactly, but where's my other one? Got one right here, and I've got one right here. So now what I'm going to do is I'm going to connect them this way, and this goes from here to here. I'm not the best artist, but do the best we can. You can use your straight edge, and then this one from here to here. So let's see what happens, what that looks like. Get my handy dandy tape here again, and now remember my A was here when I folded it. This was my A. I'm going to call that A prime. And that little slash means prime, and that's when you transform something from one location to another. And again, it just moves from there to there, but it flipped upside down. So that's what happened here. So if I flipped it, the B is here, this will be B prime. The C would be here, this will be C prime, and this will be B prime right here. And that's a reflection. So my original A was at 2, 4, B was at 4, 3, C was at 2, 1, and D was at 1, 2. Now C is at 2, -1, A is at 2, -4, and B is at 4, -3, that B prime, and then the D was at 1, -1. So those are your new coordinates for when you did a reflection across the x-axis. And if I'm going to do a reflection across the y-axis, go ahead and fold it over your y-axis and plot those new points and see where that reflection will be. And in the end, after we just are looking at these things, we should be able to recognize if the transformation was a rotation or if it was a reflection. So how can I look at that? Well, look, it's kind of reversed over here. That's a reflection. If it were a rotation, it would look like it had rotated here like this, but then things don't match up. So another way we could do that is we could cut out a piece, cut this out and see how it looks over here, and then notice they wouldn't match up. You would have to reflect it in order for that to happen. So this is how we would identify a reflection. If I folded it, did it land on the opposite side like that in reverse? And again, that's over the x-axis. Over the y-axis, it will show up over here. And those are the only things you got to know about a reflection. So rotation, we're only going to be doing. Okay, the last type of transformation that we're going to be talking with congruency is what's called a translation. And that's just pretty much is what's going to happen, so things are going to slide. So it's just taking this thing, and if I just move it to another point here and everything stays right lined up like that, it moves from this place to this place. So it went down 1 and it went to the left 1, 2, 3, 4, 5 places. And notice that everything else did the same thing. The D went down 1 and then 1, 2, 3, 4, 5 places. So down 1 to the left 5. If I took that and I said, well, I'm going to just move it, let's say right here, so my points kind of line up this way. Make sure everything lines up again so the points are where they need to be. And this one, the A, this time moved over 1, 2, 3, 4, 5 places, and then it went down 1, 2, 3, 4, 5 places. So everything moved 5 places this way and 5 places down this way. So you can move yours to wherever you want to, but you're always going to move just horizontally and then vertically. So up and down and slide back and forth, just kind of like you do when you're plotting your points. You're just moving this point from here to here. Or if you remember from slope, you could say, well, there's a line that goes from here to here. They just move from here. Same kind of idea there. So that's a translation. You're just sliding this thing around. You're sliding it here, sliding it here, and everything stays lined up. So that's what we call a translation. So those are the 3 different types of transformations that you need to know. You have your rotation that we saw the first one, and where it just rotates, everything turns around the origin. Then we saw the reflection, which I still have up here, and then we had our translation, where everything just slides one way and then down another way, or it just slides down some and then back this way. I could have slid it down here and this way, and that's a translation. And so again, when you make your translations, I need you to do 2 of your own. You don't have to do mine. Do 2 translations, slide it so many places to the right or left, and then up or down. So I can move it this way and up 1, that'd be fine too. Whatever you want to do that, and then record your new coordinates. And for all of these, the original coordinates need to be recorded. Everything else will be in A prime. So you have an A prime, B prime, C prime, D prime when we move those that way. So those are the 3 different types of ways that keeps everything congruent so that the size and shape don't change. And in fact, the shape is really just moving from one location to another. And there's a way that we're going to look at later on to identify how each one, there's a pattern as to how the coordinates change based on it being a translation, a rotation, or a reflection.